Hi there, welcome to this sigma notation lesson, which will focus on an arithmetic series. The question is indicated on the board, and we'll go through the inquiry and get to know what is the meaning of different aspects of the notation so that we understand that question, even the words that are used in the question, way before we get to the solution. That is very important, and that is what I advise in the method of inquiry, so that we get to understand the language both in words and in symbols that are used mathematically. And the combination of those two will help you understand the mathematics that is in question and also the mathematics that will inform the solution. Let us go for it. Evaluate. Okay, so value means to find the value of something. In this case, it will be the sum value of the arithmetic series. Evaluate the sum, right, of the first 400 terms in an arithmetic series. So let us interrogate the arithmetic series. We have a -5 here. What does that give us? It gives us the constant difference of this arithmetic series, and that is our variable there, which matches that, which is perfect, and that is a constant, and that gives you term 0. But you don't need a term 0, but we need term 1 when we deal with the sum, because we're working with position 1 all the way to position 400. Now, what type of an arithmetic series is this one? It's a decreasing arithmetic series because we see that the constant difference is negative. Okay, so if you have to superimpose this to this format, y is equal to mx plus c, your gradient is negative. So it's a decreasing function. So let us sketch it. That's the origin, that's your x-axis, that's the y-axis. So it will be a decreasing function, okay? And that number 2 will be your y-intercept, where your x is 0, your y is 2. What will be your x-intercept? You do the maths there, it will be 2 over 5. Okay, so term 1 will be somewhere there. We can even extend it and get to 2, 3, all the way to 400 somewhere there. So I'm going to use the graph to help you understand at the core of sigma notation what we're exactly doing. All right, so let's do some expansion process here. Okay, we don't need term 2 and 3. But, for the sake of explaining, the combination of the sigma notation and the function itself and the fact that they are similar and actually have the same end result is basically important then to get term 2 and term 3. Term 1, by substitution. This one, we substitute into the rule. -5 times 1 plus 2 is equal to -3. You go to term 2, okay, so after 1 definitely your next number is 2, so -5 times 2 plus 2, okay, so that becomes -10 plus 2, -8. Term 3, -5 times 3 plus 2, -15 plus 2 gives you -13. Okay, so what does this mean in terms of the graph? So the value for position 1 in this series is -3. The value for position 2 in this series is -8. Are we seeing that? So now, what do we then predict our value of this sum to be? It will be a -1 because predominant will be adding negative values, okay, in red, as we start from position 1 all the way to 400 because the decreasing function. Okay, so we expect our answer to be negative. We will confirm that with our calculator. Okay, so we are ready then to get to our sum formula because our A obviously comes from term 1 and the value of term 1 is -3. Our D is given, is -5, and our N is 400. Remember, this N is the first n terms that you're summing. It's very important because this function goes all the way to infinity, and you can't just say 400 terms. Where in the series are you? So it's the first 400 terms from term 1 all the way to term 400, and the values of all those terms, you are summing that to get your particular value. So it's Sn is equal to n over 2, 2a is n minus 1 times d, okay? And then we are summing 400 terms. So it's the sum of the first 400 terms. Let us understand the formulas that we are using in mathematics, very important. Okay, so this n and that n are the same. So it's 400 over 2. We multiply that by 2 times what is the value of a? Negative 3 plus 400 minus 1 times what is d? It's negative 5. And then if you plug that into your calculator, you will get negative 400,200. Did we anticipate that? Yes. The graph confirms that. Our calculator confirms that. So this is it about sigma notation with a focus of an arithmetic series that is decreasing. You can do the converse of this and do the one for an increasing function or an increasing arithmetic series, and there you will definitely get a positive value if it is a lot of terms that are positive in that regard. Okay, so I believe this was helpful, and do more of this kind. And if you have not watched the video for geometric series and quadratic series and the sigma notation, they're already there on the channel itself, so go and watch those two as well, just to enhance your understanding of this topic. All right, so thank you for tuning in. Keep well. See you next time. Sharp, sharp.